Okay, so we're starting our unit of matrices. So what is a matrix? A matrix is like a rectangular, so what we mean by that, so we have a rectangle shapes like this, these sort of square brackets, and they contain either numbers or pronumerals or things, so they could have numbers or letters, that's what they're saying, so on. And they're enclosed in these square brackets. So each of these little numbers, when you have them, they're called elements. So if you look at this matrix I just wrote there, it has 6 elements, okay? So we use this for displaying information on, certain stuff. So if we look at it, so we use it to record data. So we often label our matrix with a capital letter. So what I mean by, I could have called this one, I might call it matrix H, yeah? And I'll just say matrix H equals this. So that's what they mean by that. So down here, we've got a little example here. We said we've got matrix A here. So if you have a look at this matrix actually has 6 elements, doesn't it? So there's 6 elements, so 6 different pieces of data in there. So with matrices, we often talk about the order of the order of the matrix. So right here, and the order of the matrix is either the dimension, or you might refer to it like as the size, okay? And we say the size, and we always say how many rows it has by how many columns it has. Okay? So remember that rows are the horizontal. So if you look here, I've got 1, 2, 3 rows, and I've got 1, 2 columns. So if I'm asked the order of this matrix, I would say this matrix is a 3 by 2. 3 rows, 2 columns. So remember columns like the Colosseum, like how it has the big pillars like that? Column, yeah, rows. And so that becomes really important because there's a few rules later on where we need to know the order for things. All right, so the order of the matrix is given by the number of rows. So here I'm showing M is going to represent the number of rows, and N will represent the number of columns. Okay, so why do we need to know the order? Because if we want to add or subtract matrices, they have to be the same order. So order becomes important before we do any type of operation or something with a matrix. All right, so also now we've already talked about the numbers inside. So I'm going to write A down here again. So if I've got matrix A and we've said that these are the elements, -2, I'm just writing it out again. So if they want to refer to an element inside that matrix, they often use the little letter. So see how I go, all right, they're going to talk about an element in matrix A. And they use this I and J, where I tells you what the row, so the number in this I position will tell you what the row is, and the number in the J position tells you the column. So if you look here on this example, they're telling me here to go to row 3, and that says go to column 2. So if you look over here, 1, 2, 3, so I'm in this row down the bottom, and then column 2, that would be here. So that's where they say that's what I'm talking about, -4. Okay, so that's just if I want to, that's what the way they'll do it. So up here, let's do another example. If I said little h, what is that element? If I said little h, 1, 2, what element is that up there? Marcus?
-6.
No, up here. This one?
Oh, sorry.
Good. So this one is row 1, column 2, so that would be X. Can you see that? It's row 1 and column 2. Okay? So it's just a way of directing you to that spot. All right, it says let M equal here. So if we're just recapping like what we looked at, what's the order of M here? Who's going to tell me? What would this one, what was it order be? Remember, order is rows by columns. So for this matrix M, what's its order? So the order of this one, it's got 2 rows and it's got 4 columns. So we say a 2 by 4. So that's how we say the order, sorry. Yeah, it's a 2 by 4. You know, like when we say a photo frame, you've got a 10 by 6 inch photo frame or something like that, yeah? That's the wording that we're using. All right, so they've said let the element in row I and J and column J of M be this. All this is saying is explaining what I just explained before, that when they give a little letter and then they put I and J, I will tell you the row number, J will tell you the column number. So it says the elements of M are determined by the rule, and this is where you go. So what they are wanting us to look for, they're saying that if I was trying to create matrix, the matrix M, by using this rule. So what they're saying is I add the row and I add the column number and then I minus 1. So if you look here, I'm going to say like this. Now, if I was in this spot here, yeah, that would be, if I was using this rule, the row is 1, so I is 1, the column is 1, so it's 1, and then I would minus, just because the rule says minus 1 is 1. So that would end up equaling 1, so I'd put that there. So, and I could do that. Now I'll test another one. Let's test over here. If I was testing, so I'm testing really this spot. If I look at this spot, it's in row 2, so I would be 2, see, I. Column 4 would be, so 4, so J is 4, I, J, and then I would minus 1. So that would be 2 plus 4 is 6, minus 1, that would be 5. So that rule does not give me this, does it? Because I've already tested 2. It didn't work, did it? Because this has to be a 6. So we would just keep going and going. I won't go through it all because it is a bit, but I'm just showing you this is where it'll lead to. Often this is forgotten, this theory, all right? Yeah? You can give it a go later. We have now got matrix. We know what a matrix is. Now we have different types of matrices. So we call a row matrix is when it only has one row. So can you see here, this matrix K, it's just one row. So sometimes they ask you, put this data into a row matrix, and you can see that the order is a 1 by 4 because it's one row and there's 4 columns. Okay, so if we have, it's pretty self-explanatory. If we have a column matrix, we only have one column. And so if you look at this one has 1, 2, 3 rows, so that's why it's a 3 by 1. Okay, a square matrix, if you look, the rows and the columns are the same amount, aren't they? So I've got 1, 2, and 1, 2. So I could have a 3 by 3, and that would also be a square matrix. So say I had, I'm just making these numbers up, yeah? So if I have a 3 by 3, that's also a square. 4 by 4, can you see? Rows and columns are the same, that makes it a square. If you have a diagonal matrix, you have only numbers occurring on what they call is the leading diagonal. The leading diagonal starts up on this left-hand corner and goes down. That's what a leading diagonal starts there, goes down there. And see how that's the only spot there's numbers and everywhere else is 0? That's what makes a diagonal matrix. So you see numbers along there and everything else is 0. So you don't need to worry, go, oh my God, I can't remember all these. Remember, we have our notes in our exam, you know, so if you get a little bit confused, you can always just come back to this, yeah? So don't stress. Now we've just got an identity matrix up here as well. So the identity matrix is it is a diagonal matrix, but can you see it's only ones, okay? And an identity matrix, it's sort of, you might just make a little note, it sort of acts like a number one. So what do I mean by that? You know, if I do 3 times 1, you get 3. Is that true? See how if you times anything by 1, you get the same thing. Is that true? Yeah? Because if I said 2 times 1, don't I get 2? Yeah? I get the same thing. So what happens, if I did matrix A, and you'll see later, times the identity matrix, which we often use an I, we're going to get A. So can you see how you get the same thing? Can you see how it's like a number one? Yeah, so sometimes that can help if you remember that. All right, so we only say, and we've just got a few notes, so a null matrix is all got zeros, pretty self-explanatory that. And 2 matrices are only equal if they're exactly the same. So if you look here, they're exactly the same in terms of that we've got a, here, I'm just writing it a little bit bigger, we have a 2 by 2. So they've got this one would have to be 2 by 2 if it's going to be exactly the same. And they have to have the same element in the same spot. So see 1 and 1, 2 and 2. That's the only way they are exactly the same. So that's pretty self-explanatory too. Oh, sorry, where have I gone? So, all right. Okay, so here we're going to look at, they're going to give us some data and they're going to ask us to represent the data in matrix form. So it says up here, we've got a table of, there's 3 houses they've surveyed and they've asked how many residents, how many TVs they've got in the house and how many computers they've got. And it says construct a matrix to display the information and what is its order. So all I have to do is, it is really that simple, is I'm just changing that to, and putting it in square brackets, okay? I have now displayed that data in a matrix form and its order, how many rows has it got? Rows before columns. So it's got 3 rows and
3.
Yeah, and what type of matrix is that? Good. Excellent, well done. So now it's asked, you just got to be really careful, make sure you answer what they're actually asking. So B, construct a row matrix to display the numerical info in the table relating to household B. So they just want this written out in a row. So I've just write out, 6, 2, and 3. What is this one's order? How many rows? 1. And how many columns? 3. Beautiful. And then it says, the last one, construct a column matrix to display the numerical info relating to computers. So they just want that part. So I just write out my column. And what is its order? So what's the order of this one? Is how many rows? 3. And how many columns? 1. And now it says this last little bit is what does the sum of the elements tell you? So they're adding these up. What would that tell me if I added them up? What is it? There is 4. Yeah, there's 4. The sum of it tells you there's 4 computers in this household, isn't it? Yeah? 4 computers in total. They're just trying to get that you are understanding what that column is standing for and things like that. Okay, so sometimes we can represent a credit card number in a matrix form. And so sometimes with computer coding and all that, that's what they actually do. So matrices comes in play with things like that out in the real world. So it says list these digits in pairs, one under the other, and ignore the spaces. So often you can write out a thing. So what you have to do is they're saying just to write it like that: 3, 5, 4, 2, 8, 2, 7, 9, 0, 0, 2, 0, 3, 0, 6, 9. There you go. So that's why we can have so many combinations, because the computers and the FPOS machines and all that, they can combine it and link it around like that. So that's just one thing you can represent matrices. So then down here we've got represent each of the following network diagrams. So when you have a network diagram, it's like here where we've got some points and we've got some lines in between. The network diagram could represent towns and roads in between. It could represent heaps of things. It could represent, someone can communicate with someone else. It's just a diagram that we use. So what they want you to do is change this diagram into a matrix. And you can see, so what they're going to say, if there's a line between the 2 points, they say put a 1. If there is no line, put a 0. So we'll do that here. So if you look here, what I'm going to have, because I have 3 points, I need to have a 3 by 3, okay, matrix. And if you look, so between 1 and 1, is there a row that's going back to 1 by itself? There isn't, is there? What that looks like is often it looks like that, okay? It's not there, is it? So we say 0. Now, is there a row or a line between 1 and 2? There is, so we'll put a 1. Is there a line between 1 and 3? No. Is there a line between 2 and 1? Yes. 2 and 2? No. 2 and 3? Yes. 3 and 1? No. 3 and 2? Yes. And 3 and 3? No. So we have, can you see how this network diagram has now been converted into a digital matrix? So you could see, we're not going to do it, but can you see down, this can now be put into computing and you can do things like that. Yeah? That's what they're doing. Okay, so if we look at this the one next door, we're going to have a 4 by 4, aren't we? Because we've got 4 points here. So, and off we go. So between 1 and 1 there isn't, 1 and 2 there is, 1 and 3 no, 1 and 4 yes, 2 and 1 yes, 2 and 2 no, 2 and 3 yes, 2 and 4 no, 3 and 1 no, 3 and 2 yes, 3 and 3 no, 3 and 4 yes, 4 and 1 yes, 4 and 2 no, 4 and 3 yes, and 4 and 4 no. So can you see how we're just doing that? A 0 if there's a line, not a line, sorry, and a thing. So this one also is a 4 by 4 because there's 4 points. And no between there, 1 and 2 no, 1 and 3 yes, and 1 and 4 yes, 2 and 1 no, 2 and 2 no, 2 and 3 no, 2 and 4 yes, 3 and 1 yes, 3 and 2 no, 3 and 3 no, 3 and 4 yeah, 4 and 1 yes, 4 and 2 yes, 3 and 4 yes, and no 4 and 4. So there you go. Alright, so that one is a 4 by 4. Okay, so here they've said, here's another little application. It says represent the diagram by a 3 by 3 matrix between the towns. So we're still doing the same here. We've got 3 towns, so we'd have a 3 by 3. Between 1 and town 1, there's no paths just going to itself. Between 1 and 2, there's none, and between 1 and 3, there's 1. Now, between 2 and 1, there's no path. Now, between 2 and 2, there's no path. Now, between 2 and 3, there's actually 3 ways. There's 3 paths there, so I put a 3. Okay? And between 3 and 1, and 3 and 0. So you just write what there is. There's 3 paths between there, so you put a 3. Okay, the next diagram shows a friendship network between 5 girls. So we've got girl number 1, 2, 3, 4, and 5. The network has been represented by a 5 by 5 matrix F and matrix F. They've used the letter F for friendship. And they've said if it has a 1 in between them, that means they're friends. If it's a 0, there's not. So here down here, they're sort of giving you the element to go to. So they're saying here, go to row 3, column 4, and we can see there's a 1. And they're asking me, what does that, it says, what is F3 for? It's 1. And what does that mean? It means girl 3 and 4 are friends. Yeah? And if we do the other one, this one where we've got to go to row 2 and column 5, it's a 0. So for this example, this scenario, girl 2 and 5 are not friends. Okay, so what is the sum of the elements in row 3? So they just want you to go to row 3 and add them all up. That's what sum means. So we add them up and it's 3. And what does that tell us? What that tells me is that girl 3 has 3 friends. Yeah? Girl 3 has 3 friends. And which girl has the least amount of friends? So if we tally them all up, this girl's 1, this one's 2, 2 and 2. So girl 1, Scott, my friends. Girl 1, oh shivers, that's on the video, sorry. And most friends was girl 3, wasn't it? Yeah, girl 3, Miss Popular. Okay, there we go.